YouTube, just a quick video on this Tevo Tornado. I've had it sitting in a box for about 8 months and didn't put it together, and kind of wish I hadn't bothered, to be honest. I'm going to run you over a few things on this printer that I found, and you can make your own mind up. This is like the new CR10 super duper printer. I can't get any sense out of it really. I'm gone back to my A8, but I'll just show you a couple of things. The first thing to note on this printer is that the heated bed, which is this part here, doesn't come with any glass or these tabs. It comes with this sort of plastic sticker on it. But actually what it is underneath there is a silicone pad. I don't know if you can see that with the reflective stuff on the bottom of it. That's a mains powered silicone pad, and it's not even earthed. It's just got two skinny wires which are heat shielded. They haven't actually got the 3-layer or 2-layer insulation. They've just got that kind of material heat wrap, and they're skinny, and they go straight into the heated pad under here with no strain relief. It comes with absolutely no strain relief. I've printed that as an attempt to offer some strain relief, because obviously this carriage moves backwards and forwards, and you've got two unearthed mains cables going backwards and forwards, and this can be doing that, it can be doing all sorts, and that is a recipe for a disaster. The frame is metal, the thing that the heat pad screws onto is metal, and neither this or the frame are earthed. So not only have you got a situation where you've got two live wires relying on a solder joint on a moving platform at mains voltage, but it's not earthed. And furthermore, I'm just going to show you this pad. If I can just balance it precariously on its side here, you can see I've earthed it now. But see these skinny wires? That's the AC. The little black one there is one of the Thermistor wires, and they go into that silicone heater that's just stuck to the bottom of this glass borosilicate, or whatever it is, borosilicate glass bed, and then you've got this insulation underneath. So what I've done is I've scratched off the paint, and then on the screw that holds the bed level I've put a serrated washer on there, so that's earthed, that goes straight back through here. And then I've also screwed into the side of the aluminium extrusion and earthed it back to the case. Sorry, this camera, hold on a minute. So that goes some way towards helping out, but I'm still not happy. And the reason I'm not happy is there's no thermal fuse in this silicone pad. And the silicone pad is controlled by a solid state relay in this box, which is a $6 including shipping solid state relay. Now if that solid state relay were to fail, it would probably fail short. And if it did fail short, there would be absolutely nothing that the microprocessor could do to shut it off, because it would effectively be welded shut, which would mean that you've got 230 volts going into a silicon heater that's rated at about 550 watts, which means it's going to get very, very hot very quickly. And probably what's going to happen, given that there's no thermal fuse, is the glue's going to detach and it's going to fall on the floor and start a fire. So I'm working on a way to get Octoprint running and put my little Arduino temperature sensor on, but to be honest, I just don't feel comfortable turning my back on this printer. I'm just going to quickly show you inside the box, but first of all I'll show you the back of the box. You can see I've made, these are my modifications, the earth wire and another earth wire, which is actually this blue one, because I didn't want to waste wire going out to the bed. But then going out to the bed. But then this bed connector, I've insulated it. This bed connector, that's mains voltage there. You could stick your finger in there and get a bump off it quite easily. Not only that, and I'm not going to pull it apart to show you, but the only strain relief on this end of the cable, bearing in mind if I hadn't taped it, this would be metal up to here, is one of these clips that goes round and it's got a screw in each side, so it just clamps the wire in, and it's clamping it onto that that sort of single material insulation. Can you see what I'm getting at with a metal you know, a metal pin. So imagine what would that happen then if the metal pin rubbed through the insulation and bridged the two sides of the mains together. Bang. Now it does come with a fuse in here in the switch. However, I'll show you in a minute. Oh shit! I'll show you in a minute. And the other thing is these horrible cables just don't let you move anything without basically disconnecting the whole thing. But it comes with a fuse in here, a 10 amp fuse. 10 amps at 230 volts, too high. Swap that for a 3.15 amp fuse. That fuse would effectively fuse the heated bed. It also fuses the power supply. This is the PSU that came with it. I've swapped it out for a Meanwell PSU, which is marginally better. At least it's bought from Farnell, and you know it's got some sort of comeback. It's probably not a terrible power supply, but it's very, very cheap. 24 volt power supply. I think it's rated for about 8 amps. And the joy of joys, the fuse and the switch were on the neutral when I took it apart. So basically what that means is, if you were to not unplug this from the wall and to turn it off, that's on, but off, open it up and think you were safe, or indeed even undo this, which is, don't forget, feeding out the mains power to the bed. So you switch it off, you unplug that, you stick your finger in there, you get a bang off it. Because it's fused on the neutral, which means that even if you flick the switch, the live is still at mains potential, or the live cable to there is still at mains potential. So that is just fucking ridiculous. I'll show you another couple of things here. So I've opened it up to show you. That was the stock PSU. I've put the Meanwell PSU in there. Slightly better, but you know, that's the solid state relay, and how it's working is that the one side of the solid state relay goes to neutral, the other side goes to the bed, and then the mains is just powered straight off the mains going up to this skinny little cable here. And as I say, the switch and the fuse were on the neutral originally. So watch that if you've got one of these printers. These ground wires or earth wires I've put in, they weren't there. So now I can't do it with two hands, but now if I touch either the case or the frame or the bed under here and link it back to the earth plug with continuity, I've at least got that level of protection. And before I didn't. And not only that, if I'd have opened this up with it plugged in but switched off, everything here was live. And there was a cover on the original one, there isn't on the Meanwell one. Another little gripe is that the spade connectors they give you are not loops, they're just literally spade connectors. So they could fly out, touch the inside of the case and liven it up. Obviously the wires are completely nothing to do with what they should be. What I am going to do is I'm going to put a dedicated 3 amp, or maybe even lower fuse on the main to the heated bed, and I'm also going to put, there's a 5 amp fuse in the Meanwell power supply thing, and I'm also going to put a 3 amp fuse on the line to the hot end. Now I don't know any way of protecting this against failure. Like I say, if it fails, it's going to probably fail on or shut or closed. The only way I've thought of so far is my little temperature monitor independent with the relay on the plug, or Octoprint. But one other gripe with this whole setup, everything on this board is fake. All the components on this board, this is a Maker's Gen 1.4 board, it's basically a Ramps 1.4 board with on a surface mount components. But the FTDI chip on there, I had a hell's own job updating the firmware. And the reason turned out to be it's a fake FTDI chip. The only way I could get it to update the firmware was using an old Windows 7 laptop on 32 bits. Anything else wouldn't work. So I've got to take that board out and graft on a new FTDI chip just to get Octoprint to run, which is the Raspberry Pi sort of monitoring program, with a smart plug, a TP-Link smart plug. And the idea there is that if the temperature in the thermistor or the bed thermistor goes out of bounds, the Raspberry Pi will send a signal to the smart plug to shut it off. I would prefer a thermal fuse. I can't see why, for the sake of 50p, they can't include a thermal fuse. Anyway, that is how far I've got with it. I've got to up the stepper driver vref a little bit. But while I was in there, I just thought I'd show you some of the horrors that you can expect from this printer. Now I wouldn't mind, but I can't even get decent prints out of it. As you can see, I've put a BL touch on there, I've put a glass bed on there, I've put big wheels on the base here. The bed was warped out of the factory, that's why I've put the glass on. So, to be honest, for 200 odd quid, I'm sticking with my ANET A8 upstairs. It's much more reliable. Like I said, I had this, I didn't put it together. But the only thing I can say about this I like is the frame, to be honest. I did take apart the extruder. The cartridge looks to be fairly well, you know, mounted, because it's in this metal case, so it can't actually slip out and fall out, which can be a problem with these things. But yeah, I mean, should have left it in the box, or probably shouldn't have had a drink and bought one off the internet. Anyway, I hope everyone's well, and I'll see you all soon. Cheers, bye.